Hi guys, Mr. McIntyre here. Going to continue with the quadratic graphs, but we're going to focus today on the form ax squared, or f of x equals ax squared and y equals ax squared. Now, what's important about this form of graph is that they always pass through the origin. It's just whether they pass through at a maximum turning point or a minimum turning point. And that obviously depends on whether you have a smiley face or a sad face. So on the right hand side, you'll see there, if a is less than 0, it's a maximum turning point. If a is less than 0, then it's a minimum turning point. So actually, if a is less than 0, it's a smiley face. Oh, sorry, that's all right. Sorry, it's a sad face. And if a is greater than 0, then it's a smiley face, or is it positive? Okay, so if it's less than 0, it's negative, and therefore a sad face. Greater than 0, it's positive, and therefore a smiley face. As you can see here, we've got a number of examples that are both positive and negative. You can see the smiley face examples. We've got half x squared, 2x squared, and y equals x squared. Now, the bizarre thing to recognize is it's very similar to gradient. The larger the value of a at the front, so 2x squared there, you'll see is steeper. Okay, whereas as you get smaller and you've got fractions, the value will therefore make a graph that is far more shallow. Okay, the standard form y equals x squared, there's a 1 at the front. That negative values, same kind of idea. In all honesty, looking at this negative value, looks like it follows a similar path to the minus 3x squared. Just to recognize that there is a difference, because the 3, you probably want something that's slightly more shallow, and should I say slightly more steep. But ultimately what we're looking for is recognizing the basics, that we have a constant at the front. If it's positive, it's a smiley face and therefore goes to a minimum. If it's negative, it goes to a maximum. And we can work out the value at the front by taking some of the key elements of the graph, or any point on a graph. So I've just drawn over the graph there. If I do a very quick one, just so you're aware, if we have f of x, or y equals f of x, and I have the graph of y equals negative 5x squared, and because there's no additional value, then that negative is going to mean it's a sad face, and we don't have any frame of reference here at this moment in time, and it's going to go to a maximum at the origin. Now, only if we decided to have something that was a little bit smaller than the 5 would we be able to relate that. So for example, if I was to draw a red graph that was slightly more shallow, then that red graph could be something like negative 3x squared or negative 4x squared, where the 3 is less than the 5. Okay, equally, if we were to go a little steeper, then that could be something like y equals minus 8x squared. And the same is true for the positive. Okay, if we have our 2x squared, or y equals 2x squared, then the higher or the steeper we get, then we're expecting something along the lines of, say, 7x squared. Now, like I say, there's a constant, and it's the letter a in the first example, but any value at the front there, the constant, okay, whether it's k or whether it's a they use, it's just an unknown value. So don't worry if it's k or a. We're going to find that value, okay? In this question, they call it k, so we're looking to find what that k value is. Now, what we've got here is much like when you were dealing with a straight line and gradient. We have 2 points, a point, with 2 coordinates. We have an x coordinate and we have a y coordinate. We also have the actual equation, y equals k times x squared. Now, what this means is that we can substitute our x is 2 and our y is 12. So those values can be substituted in here. Now, what we've got, actually, the number of unknown values we've got within this question is we've got an unknown y. Well, we've actually got a known y now, the k, and we've got the x. We only need to know 2 of the 3 to work out the third one. Much like when you did speed, distance, time. This is what I always use to remember this. When you did speed, distance, time, you only needed the speed and the distance to calculate the time, or you only needed the time and the distance to calculate the speed, and so on. So what we've actually got is we've got the y value from up here, and we've got the x value from up here, and they come from the point on the graph. So actually what we've got is substituting in, instead of the y, we would use 12 k times x squared, so 2 squared. So actually what we have is we have 12 equals 4k, because that's k times 4, or 2 times 2. Now what I would have taught you before to solve this was just be flipping. So 4k equals 12, so k equals 12 over 4, and therefore k equals 3. That means we can just take it over to the side here. If k is 4, then the final equation is y equals kx squared instead of k. Sorry, k is 3, sorry. Instead of k, we'll put in our 3. So that's the equation of the line. Okay, guys, we're going to go through a second example here. What we've got is we have an equation of the form f of x equals kx squared. We mentioned before that the f of x and the y are interchangeable. You will see both. So what we need to do is we need to take values from the graph, or from this point over here in the graph, to substitute into the equation to find the missing value. We have minus 2 minus 18 is our only point lying on the graph. That's absolutely critical. It has to be a point lying on the graph. We can't have a point sitting up here and take those values. It has to be a point that lies on the graph. So first thing we've got is we've got the x value is negative 2, so x equals negative 2, and the f of x, or the y, is negative 18. So f of x is negative 18. Now, the eagle-eyed of you will recognize that when we square this negative 2, it's going to have a massive impact on the answer. So f of x equals kx squared. Substitute in, we have negative 18. Make sure you bring the sign. We have k times negative 2 squared. It's worthwhile saying that that negative 2 squared is negative 2 times negative 2, which is going to give us 2 positives, a positive, 2 negatives to multiply to get a positive, and that is 4. Therefore, we have negative 18 equals 4k. Now, the reason I wanted to show you this was twofold. I wanted you to see a negative value, and I also wanted you to see that it's not always going to be as neat and tidy as something like 16 divided by 4. So we'll go through the normal process. We'd flip it to get our simplification. The k equals negative 18 over 4. So right there, we have a k value. We're just going to have to find a common factor. The common factor is 2. So we've got negative 9 over 2. So that's okay. It might look messy, but that's okay. What we're going to have as our final answer over in green for the equation is f of x is therefore negative 9 over 2x squared. And that's just taking this value straight into the formula that we started with. Now, does that ring true? Is that a sad face parabola? Yes. Does it go through the origin? Yes. Okay, that's the beginnings of it. Hopefully you find that stuff pretty straightforward. It's just substitution into formula. Just be mindful of the double negatives and make sure you solve carefully. Okay guys, so let's take the stuff we've learned about the standard graph, which you can see on the left hand side. You see in the pointer, the f of x equals x squared. It's a positive graph with a smiley face that goes through the origin, turning point 0, 0, and it acts as a symmetry. It's just x equals 0, or in other words, the y axis, or the f of x axis. So this axis has an equation of x equals 0, and that's why it's the axis of symmetry, which we've actually looked at before. Now, what we want to look at are the two possibilities where we have a shift along the x-axis. So as you can see in the diagram to your right, the f of x shifts, the f of x equals x squared, shifts to the right by 2. And at the beginning, we were looking at the graphs of form f of x equals ax minus b squared, or y equals a bracket x minus b squared. And that minus is something we're going to look at because technically it can be plus or minus and it determines the move. In this first example, I'm just going to show you the shift to the right hand side. So naturally you would think normally that if it's got a negative 2 inside there, that would mean we would move 2 spaces to the left of the origin, but actually the reverse is true. So because we're shifting left and right and it's along the x-axis, the movements left and right are connected to the x, or in other words, they're in beside the x inside a bracket. Something that's disconnected from the x is something we're going to move on to at a later date. But for this one, there's a minus 2 in the bracket, so actually the reverse, we work and it moves to the right-hand side into the positive. Okay, now what that does is it means it shifts the turning point. That turning point that we had at the origin is now shifted along the x-axis too. So the turning point is now 2, 0. And because that value is x equals 2, that means the line of symmetry, or the axis of symmetry that goes through the middle, is now x equals 2. So little shifts left and right sometimes can have a big impact on some of the key points we're looking for, whether it be roots, turning points, axes of symmetry, where it crosses the x or y axis. Now, it's worthwhile recognizing down at the bottom here, we've actually got the graph I was talking about where it could be a positive inside the bracket. And because if it was a positive value, then it would shift into the negative. So in other words, if we had another graph like so, and we had shifted to -3, then actually the graph of that would be, and I've used y rather than f of x, the graph would be y equals, we're going to say that the a is 1, so x plus 3, and it's a square term. A couple of key things. It's still a square term because it's still a parabola, and the plus 3 is because we've moved actually into the negative side. So moved into the negative side means that inside the bracket is positive. On the top one, we moved into the positive side, so inside the bracket is negative. Very quickly, let's do a recap with a slightly different graph. Looks very similar. We have -7 down here. Let's see if we can find the turning point and the axis of symmetry. So we've got f of x is ax plus b squared. So we need to find the values for a and b. I'm going to tell you that to keep things simple at the minute, we're just going to have a equal to 1. So we're only going to be dealing with f of x equals x squared. What I want you to find out is this bit in green. So the graph has moved from the origin, it's moved into the negative side. So actually what goes inside the bracket is the +7. What impact does that have on the turning point? That means the x value of the turning point is -7, still lies on the y-axis, so -7, 0. -7 is also where the axis of symmetry is, so that's x equals -7. So the axis, or the equation of the axis of symmetry, is x equals 7. I should put in their equation. Okay, now let's look at the graph. Rather than moving left and right, let's see what happens when it moves up and down. In this case, when we were moving left and right, we had this strange opposite rule. When we're moving up and down, it's just straightforward. If you're adding at the end, it goes up. If you're subtracting, it goes down. So again, if we look at the standard form of fx equals x squared, turning point still 0, 0, axis of symmetry is x equals 0, and the a is 1, as we said, right? So we're going to assume that a is 1 for these examples. So what we've actually got here, and I'll use some colors just to make it clearer, is we've got a red graph that's moved up quite clearly, and we've got a blue graph that's moved down. Now, what we want to look at in the first instance is we want to look at where it should start. That point, that red point right there in the origin, that's 0, 0. That's our standard form. And this equation for this line here is still f of x equals x squared. Now, I said before that if we're moving left and right, the change would be inside a bracket, right? And that's for the left and right. But we're not moving left and right. We are going to move up and down. So in this case, if we were to take the blue one, we've got f of x, it's x squared because we've still got a parabola. It's still positive, still a smiley face. But what we've actually done is we've moved from the origin and we've dropped to -2. Because it's not a movement left and right, it's not connected to the x-axis. It's connected to the f of x. Now, we can't put it in beside the f of x. What happens in this case is it just goes straight after the x squared. So that is f of x equals x squared minus 2, as you can see here. Now, the red one, very much the same thing. We've still got the same style, same size of x squared. This time, however, it's moved from the 0 up 3. So at the end, it's just plus 3, as you can see here. So the only real difference between them is when it's an x value, we're going to have brackets. So when it's shifting left and right, it's in brackets. When it's up and down, it's not. What happens to the turning points? So this time when we're up and down, as you'll see down the bottom here, okay, for f of x squared plus 3, the red one, we've got 0 is still our axis of symmetry, or x equals 0. So the x value is 0, but it's shifted up. The turning point is at 3. For x squared minus 2, it's dropped down, so it's 0 minus 2. Right, what we're going to do now is we're going to have a look at what happens when we combine those two movements from the left to the right and up and down, or movements left and right and up and down. As always, we're going to start by concentrating on the f of x equals x squared. So this graph here just starts off, actually f of x equals x squared. And that just tells us that it's a parabola. Okay, we now know that we can move left and right and up and down. So this standard form, what we've got to look for is what movements has it taken to the right or the left, and what movements has it taken up and down. And in this case, you can see from the orange or the yellow and the green, it's gone to the right and it's gone up. So what that means is it's moved to the right by the value of b, and it's moved up and down by the value of c. Okay, here. Now, those numbers are going to change. We don't know what they are. It's much easier to fit these in when we have numerical values and to explain the movements. The last thing we know is that now not only has that turning point changed and become BC, but the axis of symmetry, straight down the middle here, has also shifted. And that's shifted to the amount that is the same as the x movement. Okay, and we've looked at that before, where the axis of symmetry, the equation of the axis of symmetry is x equals, and in this case you'll see below it'll be x equals b. Now it's much easier to see this when we have numbers. I do want to draw your attention to the section on the right hand side here, And this f of x equals ax plus b squared plus c. Now, the reason I want you to look at that is they've actually put in here the plus b because this graph has moved to the left. It's going to be a positive value because it's moved into the negative section. But ultimately, don't worry about how this original equation is set up in the question. We will look at how we think about that because they do try and trip you up a little at times. But what we're really wanting to focus on is the left and right movement and the up and down movement. Now, I do also want to say, you'll see here that A is -1. This is because we've got a negative graph, okay? And that is, as we know, is the sad face. That's where it's upside down. So in that equation, you would have f of x, and you may have, if it's got a left and right, you may have just a negative value at the front. So whatever it could be, +3 squared and +4. Well, in this case, it would be a negative because it's dropped down. But that negative value at the front tells us that it's a sad face, and that's important to remember when you're looking at these graphs. Like I said, this is a lot easier to see when we've actually got numerical values. So I'm going to run through a couple here. Well, first of all, we're going to look at example 1, which has a positive value. So that's why you see the smiley face, and example 2, which has a negative value. So the equation, and we're not actually going to fill in the blanks. I'm just going to show you the connections between the equation and the main points. So we've got our turning point is in the positive side of the x-axis. So it's 4 and 1. We know that when it's a positive, inside the bracket is going to be negative. So x minus 4 comes directly from this x-axis, or this x point 4, 1. We also know that that means it's moved to the right. Okay, so it's moved to the right, it's a negative value, and it's moved up 1. That's why for the 1, it's up 1. This time the +1 is outside of the brackets, and that tells us that it's moved up. Okay, now if it was negative, it will have moved down, but it's important to recognize that it's external from the brackets. The brackets are the bits that tell us next to the x, the left and right movements. The stuff outside the brackets or after the squared term tells us whether it's up and down. So we have the equation y equals x minus 4 because we've moved into the positive side. That's where we're dealing with the opposites. Squared plus 1. Now, the turning point, as you can see below, was already highlighted, but the important next step is the axis of symmetry. The x value on the turning point is 4. So the axis of symmetry is the straight line through that x value. And the axis of symmetry is always just an x equals value, right? So on to example 2, same idea. First thing you'll recognize, hopefully, is it's a negative in front of the x squared, so it's a sad face. The turning point tells us now that it's shifted to the right 2 into the positive side, so it's -2, and up 3, so it's +3. So we have the negative tells us it's a sad face. We have the -2 next to the x value tells us it's shifted to the right 2, and the +3 means it's gone up 3. And once again, the axis of symmetry now has shifted, and it's the equivalent of the x value in the turning point. So the turning point is 2, 3. Equation of the axis of symmetry is x equals 2. Now, I've just written axis of symmetry. That should be the equation of the axis of symmetry, but hopefully that's a little clearer. Now, the last little part of this is to try and tie in with some of the other topics you've covered. Now, most of you, and I mentioned it at the beginning, most of you will recognize that these terms here are much like the terms you'll get when you are doing completing the square. Okay, so I want to have a look at how we may go from a term that you need to factorize using completing the square and then start to move towards the graph. Okay, just a quick reminder on completing the square first before we have a look at it. We've got a term that we need to factorize. We've got x squared plus 6x minus 3. What would happen is you would Have a look at the question. The key thing it tells you, it will always ask you to leave it in this form, and that gives you the hint it's completing the square. If not, you would have gone through your window method and you would have seen that it wasn't something that would work. So then the first step is you take half of this middle coefficient, which is 6, x plus 3, all squared. You then subtract 3 squared, which is minus 9. So actually there's a step at the top here, which would be minus 9 minus 3, and that gives us our minus 12. Now, what do these values mean in terms of the graph? This plus 3 inside the bracket, is that a left or a right movement? The plus 3 tells us that it's actually moved in the left direction. It's gone left 3, okay, gone left 3 from the origin. It's a positive 3, so the movement is negative. So that's a left. Okay, the minus 12 also tells us that it's, well, this time, sorry, it's disconnected from the x. So it's just a straightforward, no opposites to worry about, just a straightforward drop by 12. So down 12. Now, it's sometimes useful to actually summarize what they are before you start thinking about sketching it. Now, what impact does that have in the graph? Okay, so we said before that the movement was 3 left and 12 down. Okay, now the graph and this point where we get 3 is something we're going to look at a later date. But at the moment, we would have been starting at the green at the origin. We will have moved left 3, okay, and then down 12. So the turning point now is it's a minimum, first of all, because it's a positive parabola. It's -3, -12. What we haven't mentioned is what is this line? What is the equation of this line? The dotted line is the axis of symmetry. We know that the axis of symmetry, the equation, always starts with x equals whatever the x value is for the turning point. So x equals -3. Now, the last thing is, how do we draw this accurately? That's quite a rough sketch. How do we know this point -3, that it's crossed the y-axis? Okay, we've got the equation that we had at the beginning. The equation was y equals x plus 3 squared minus 12. Now, how is it I can get -3 from this? We need to find the y value here is -3. When it lies on the y-axis or the y-intercept, we know that the x value is 0. We've done that before with the straight line. So at x equals 0, if we substitute x equals 0 into the original equation, what we have is y equals, let's do it in red so we can see, 0 plus 3 squared minus 12. Now, if we deal with the brackets like we would do first, 0 plus 3 is 3, 3 squared minus 12, or 9 minus 12, which is -3. So that gives us the y-intercept, the point 0, which we picked, and the resultant y value, -3. So that is now our y-intercept. That's another point on the graph that makes it possible for us to be a little more accurate. Okay, let's now look at a negative example. Now, this is quite a complex completing the square question. So if you're not sure how we move from f of x to minus 3x minus x squared to f of x with a negative at the front, that's something we can look at for completing the square. And I don't want to labour over that just now in case it causes some confusion. What I do want to focus on are the key elements of this graph here, this function. And they are, of course, the negative value at the front here, which tells us it's a sad parabola, a sad face, or a maximum turning point. The +3 inside the bracket, which tells us we're going to move left, okay, by 3/2. And the plus 4 1/4, which tells us we're going to move up 4 1/4. And those are the key points. So the negative gives us our maximum turning point, or our sad face parabola. The plus 3/2 tells us we're actually going to move left because that's inside with the x. And the plus 4 1/4 means we're going to move up because it's not connected to the x. And I've summarized that on the left-hand side. It's a negative graph. We've got all our key movements. We've got a maximum turning point. The maximum turning point now is the movement left, negative 3/2, and the positive movement up 4 1/4. So as you can see, from the origin, this graph has moved left and up. Okay. It also tells us that the axis of symmetry will follow, as before, the x value of the turning point. So the equation of the axis of symmetry is just x equals negative 3/2. Okay, quite a complex function, I have to say, but it's just to let you see what happens when you've got all that mixed in with left movements, right movements, up and down movements. I think I will go and just do a very quick example of how they might rearrange this in its factorized form and see how you would tackle that too. So bear with me, I'll give you a quick additional example. Okay, in the exercise you're going to face with completing the square, you might see the functions displayed like we see on the left-hand side. So I want to just take a couple of examples and show you how you would rearrange it into the standard form before you start thinking about maximum turning points, minimum turning points, positive and negative graphs. So if we take, just for a very quick example, we take B first of all. We've got y equals 8 minus x minus 3 squared. Now, obviously, that just makes things a little bit neater because there's no negative value at the start. But what I want you to do is, you know that the positive and negative comes to the front. So the bracket with the x minus 3 squared should be at the front. And if there's a positive or a negative value at the front of that, it must go in there. So actually what we've got is we've got negative x minus 3 squared. That 8, okay, that was at the beginning, okay, is positive 8. So we can't just get rid of that, but that should shift to the end. So that tells us that we've got a sad face parabola for the negative. We've got a shift to the right of 3, and we've got a shift up 8. Okay, now if we take a second example, let's take G, slightly more complex than this one. Minus 5 minus x plus 3 squared, still dealing with 3. I don't know why, that seems to be the common value. So what we want to do is we want to again take the negative x plus 3 squared to the front. This time the value at the front is a negative, so we've got negative 5. Now what do they translate as for movements? Well, the negative tells us again it's a sad face. The plus 3 now tells us that we're moving to the left 3 because it's an opposite, and the negative 5 means we're moving down 5. Okay, so rearrange it first into the kind of standard form with the x squared bracket at the front, and then look at finding your key points, your turning points, your areas where the graph crosses the x-axis or x or y-axis if it does, and your equation of the axis of symmetry. If I was to take that in its full form, let's have a look at G, which we looked at there. We can say that the turning point that we've got from this left movement, negative 3, so the turning point will be negative 3. And the y values are dropped, so it's negative 5. That means that the equation of the axis of symmetry is x equals minus 3. Now, if we were looking to see where it crosses the y-axis, we would go straight into this equation and make x equal to 0. And before we did that, that would give us our y-intercept. So we would process the formula and get our y-intercept.